Hello, today we're going to go over a technique called limit swapping technique in evaluating definite integrals. Typically, the way you evaluate a definite integral is you find an antiderivative for the integrand and then you plug in the endpoints and you subtract. But in many instances in math competitions, it is impossible to find an antiderivative. However, it is possible to find the definite integral. Here's an example. This is a very famous one. I will do this one and illustrate what this method entails, and then I will also give you some other examples to work on. So here's the problem. Problem A3 from 1980, Putnam 1980. Evaluate the integral from 0 to pi over 2 of 1 over 1 plus tangent of x to the power of root 2 dx. If you try to evaluate this integral using the antiderivative technique, it is really impossible because finding an antiderivative for this function is impossible. If we try to swap the limits of integration, that gives us a nice way of evaluating this integral. Let me first write down the integrand in terms of sine and cosine. So if you write it down in terms of sine and cosine, we get sine of x to the power of root 2 over cosine of x to the power of root 2. And then we are going to clear the denominator here. We get cosine of x to the power of root 2 plus sine of x to the power of root 2. And the numerator is going to be cosine of x to the power of root 2. So here's the idea of the limit swapping technique. Sometimes people call this a specific type of limit swapping the king property. We're going to use a u substitution that swaps the limits of integration. In other words, I am looking for some u that when x is 0, u is pi over 2, and when x is pi over 2, u is 0. So if you look at this one in the ux plane, it goes through this point and this point. When x is pi over 2, u is 0, and when x is 0, u is pi over 2. So the line is this. And clearly this line is u equals, the slope is -1, so negative x, and the intercept is, u-intercept is pi over 2. If you do this u substitution, what you're going to end up getting is integral from 0 becomes pi over 2, pi over 2 becomes 0, cosine of x, that becomes cosine of pi over 2 minus u to the power of root 2, over cosine of pi over 2 minus u to the power of root 2 plus sine of pi over 2 minus u to the power of root 2. Those are values of x. dx is negative du, so that's negative du. Now we're going to use a negative sign and swap the limits of integration. So that gives us integral from 0 to pi over 2. Cosine of pi over 2 minus u is the same as sine of u to the power of root 2. Cosine of pi over 2 minus u is sine of u to the power of root 2. And sine of pi over 2 minus u is cosine of u to the power of root 2. Now, if I call the initial integral I, this is what I got. I got I, the initial step gave us this integral from 0 to pi over 2. The denominator was, if you look at what we had at the beginning, it was cosine to the root 2 plus sine to the root 2, and the numerator was cosine. So it was this, cosine of x to the power of root 2 over cosine of x to the power of root 2 plus sine of x to the power of root 2 dx. Now, when I did the change of variable, when I did the u substitution, I ended up with the same thing except that the numerator became sine. And I'm going to change the u to x back to x because that's just a dummy variable. So I ended up getting sine of x to the power of root 2 over, and the denominator is the same, is cosine to the root 2 plus sine to the root 2. So it's the exact same denominator. I just swapped these two. Now watch what happens when we add these two. We get twice this integral equals the integral from 0 to pi over 2, and the integrand becomes cosine to the power of root 2 plus sine to the power of root 2, since the denominators are the same, over the same thing, cosine of x to the power of root 2 plus sine of x to the power of root 2, which is equal to integral from 0 to pi over 2 of 1 dx, and that is in fact pi over 2. So therefore I is going to be pi over 4. So the given integral is pi over 4. Now it doesn't have to be this specific transformation. It could be different types of transformations. So for example, if you are given, and I will give you examples in other videos, if you are given something like integral from 1 to 2 of f of x dx, you could do a u sub to be either 3 minus x, so this gives you, when x is 1 you get 2, when x is 2 you get 1. You could also do a u sub of 2 over x. This is another one. When x is 1, u becomes 2. When x is 2, u becomes 1. These are two possible scenarios. And then this might help you evaluate this integral. So if you like this video, make sure to subscribe to the channel where you can find more videos like this. And you should be able to see on your screen similar videos to this video. And I will see you in one of those videos.